Welcome to Catalyst, a program about people, ideas, issues, and conversations around them.
Welcome to Catalyst. I'm Doug Webster, your host of the STEM education series, A Renewed Culture of Innovation. STEM stands for Science, Technology, Engineering, and Mathematics. This series was developed to discuss key issues around stimulating interest in technology, creativity, and innovation, and to help strengthen science, engineering, and technology education. Today's episode is Robots in Education, Technology-Motivated Learning. And joining us today is Jim Dermeyer, instructor of pre-engineering at the Center of Technology, Essex, and two of Jim's students, Matt Spencer and Brian LeClaire. And I also understand, Brian, that you are with the Essex High School.
Yes.
So welcome to the show.
Thank you. Thank you for having us.
Great. Now, last weekend you competed in the first competition out in St. Louis. Can you describe what that was all about?
Well, basically, there were 128 teams in the first tech challenge, first standing for the inspiration and recognition of science and technology. And we all came to St. Louis, previously qualifying in regional matches and state matches. And we competed to see which robot was the best and at what the given task was, which it was very complicated, but the basic idea was get a racquetball, put it into your crate, and then stack the crates as high as you can.
Mm-hmm. Well, now, I see you also brought a friend here. Can you tell us what this guy's all about?
Well, this guy down here, his name is Bordeaux, as we like to call him. This is our competing robot that we actually originally designed the concept for this guy in about 10 days and dragged that 10-day robot to our regional competition with us. And the robots that we have to fit in within 18 inches cubed, so 18 by 18 by 18. So it can't be too large.
Right. And when we went to that competition, Bordeaux, he tried his best, but there were some flaws in them. Like any robot, they'll have flaws, and well, anything in that for that matter. And we finished third to last in the competition, but because of the Inspire Award, which is teams, it's an award that's given out by FIRST that says teams want to be like you. You resemble what FIRST is. That we received it, and because of that, we were given the ticket to St. Louis to compete. And to tell you the truth, we were just ecstatic and overjoyed.
Excellent. Great. Jim, can you tell us what your experience was like as an instructor?
Well, it's an incredible experience as an instructor to be able to coach, and it is really coaching young students like Brian and Matt, who just get really enthusiastic about building these robots, and you know, as is in the name, true to the name, they get inspired, and with that inspiration, with that hook, I like to call it, you can do a lot of things. Mostly, engineering is working hard, and if you can learn that at an early time period, like when you're a teenager, and you can get just enthusiastic about it, it's going to go a long way when you dive into a career in engineering, math, or science, or technology. So it's always great to see these guys perform and really rise to the task. And they did. They did a fantastic job. A lot of long late nights, a lot of problem solving, and a lot of learning. That's what engineering's about.
Yeah. Now, how did you first get involved with FIRST? Jim, you're probably the
Well, we started 4 years ago. We started with our team 4 years ago, and like anything, you have to dive in. Our first competition down in Massachusetts was,
Yeah.
well, it was dismal. I think it's the best word. We did place last. But in doing that, just like Thomas Edison failing so many hundreds of times with creating the light bulb, you learn that part of engineering is failure. It's learning from that failure. So it was a great opportunity for us, and we did. We learned from it. We came back. We said, what went wrong? We asked ourselves, how do we do this better? And that's part of engineering. So, and that to me is the essence of STEM, is learning from failures, from mistake, trying things out. And they may not happen the way you want them the first time. But eventually you try, you keep trying, you experiment, and you get better at doing what you do. And so the next year we came back stronger. We took a 3rd place in the overall competition amongst about 30 teams. And the year after that, which was last year, we took a 2nd place in the first Northern New England challenge. And then this year, of course, we won the Inspire Award. So,
Great.
And the shot at the championship, the World's Championship.
Great.
So that's what the road's been like for us.
Yeah.
Good, good. Takes a little while sometimes to get
Yes.
this.
Oh, yeah.
Yeah, so as far as Matt and Brian, how did you get involved with it first? What, did you take a class and?
Well, freshman year was for me was the first year that the robotics team was started. So, and I had Mr. Dormeyer as a teacher, and he was talking about it, and I was interested, and I said, what the heck, I'm not doing anything this afternoon. I went and checked it out, and from the moment I got there, I was hooked. I mean, I loved that we had the ability to make this robot, not to battle, not to fight any other robot, because you never want to see something that you've worked 5 months on get destroyed. And able to work with each other, get some awesome experiences that I wouldn't be able to have if it weren't for it. And I don't know where my education, where my life would have been without it. And like Mr. D said, first year was dismal. We learned from that, and we came back stronger than ever and probably had the most unique robot when we came back our 2nd year.
Yeah, right.
As for me, I've been programming since I was 10 years old, and I hadn't been involved in any real engineering challenges or anything like that. But last year I took the class that we actually have at Essex High School for robotics. And
what class is that?
it's taught by Joe Chase, another one of our mentors. And it's for any grade level between freshman and senior year. And it involves mostly with Lego parts and using the same microcontroller we use on here, the Lego NXT. And you learn a lot of programming, things like that. Basic challenges are done throughout the class, and it's semester long.
Yeah. Well, speaking of technology, can you describe what is in there? What do you have going on in there?
Well, most of the parts in here are actually Legos. It's built by a Lego company called Tetrix. It's the metal bars you see right here and on the back. And then this year's competition, you need to do a lot of customization, a lot more than any years past. Right here we have a scissor lift. Basically, it'll go up, start really small, but extend really high up. And all this is aluminum channeling. And we had to fabricate it. We had to drill all the holes. We had to use all the nuts and bolts and make it ourselves. And it was a lot of long nights, but it was a great learning experience.
Now you mentioned this is a class or a club. When did you do most of the work on robot?
We gather as a club, but it's more of a team as we see it now. And it's after schools. We started off this year on Wednesdays and Thursdays. And coming up to our regional competition, it starts in September, and then the regional competition that we competed in was in March. And getting closer to that March, starting in about at the end of February during our February vacation. We met every single day. We put in that week that we had off, we actually put just probably about 60 man-hours each into building the robot and working on it. And then we also had some really late nights leading up to that competition. And so there's a crunch time where it starts getting closer and closer. And after our competition, we started working with a group from Richmond called Green Sea Systems, who build aquatic robots. They have robots that have gone to the Titanic and things like that.
Yeah, this is a company in Richmond.
Yeah, company in Richmond.
And they really helped us out a lot through our building methods and how we work together, and a lot of the technical aspects of a robot as well.
Oh, cool. Great. Now, I understand you have a Fab Lab at the center in Essex, or the high school. Where is that? And what is that?
Well, a fabrication lab, or as we call it for short, Fab Lab, is a joint venture. So it involves the Center for Technology Essex, and so we're supplying some equipment. The Essex High School, which is supplying some equipment and a location at the high school, and also in conjunction with industries. So the idea is to have a joint venture where students can do projects like this in not just the after-school clubs, but also during classes. If a math class wants to do, cut out pieces for a model to put together to do different tessellations or different shapes, geometric shapes, they could do that. Or a physics class could design and build trebuchets or something of that nature to show principles of physics. Or a tech class could print out models that we design on a CAD system using SolidWorks. That kind of collaboration we feel is going to be really strong, and it is the essence of STEM. I mean, that's of all those elements coming together.
So the Fab Lab is it's operated both by the high school and the Career Center.
Correct.
And Joe Chase is another instructor at the high school. The two of you collaborated, as did the students, right? So,
correct, yes. And there's actually a committee as well of other people, and including committee, on the committee are people from industry, John Cohn, among others, who are having input to what equipment should be in here, and what's also going to be good for people, anybody coming from the outside. If a company wants to come and say, run a rapid prototype of an object for their new product, they can do that. We'll have a laser cutter, a dimension printing machine, and CNC machines, both a CNC mill and a CNC lathe that we can cut parts out on. So it's a really, it's a small prototyping lab that companies as well as our classes can use for making and creating.
Oh, great, great. Now, as far as competing in the first competition and coming together and all that, what were some of the barriers you had to break through to be able to do that, yet either in the community or support or within the school, scheduling, that type of thing? What were some of your challenges?
Well, we've been very lucky, for one thing. We have a great community in Essex, and we've been supported fully by the Center for Technology Essex director, Bob Travers, as well as Rob Reardon, the principal at the high school, and everybody in between. So it's great to have community support. We've had a couple raffles. We've done some fundraising, which is always necessary for this type of thing. And in the process, had a lot of fun too in the community, and gotten out there and shown the robot to kids of all levels. It's some of the barriers. First of all, just getting to be known. I mean, that's getting to have people know what we do, how much we spend on and involve ourselves with the building of these robots, how immense this whole experience is, and you know this now that you've been to St. Louis
Yes, yes.
at the championship competition, of how many other people are involved.
Yeah.
30,000 people in an arena. Very excited about competing with the robots and seeing these robots work and compete. So that's really the barriers, to get people to know that there's this huge machine out there to help young students get energized about engineering.
And the nice thing is, it's not just the STEM community that's learning about this. Last year, in the previous competition, will.i.am of the Black Eyed Peas signed on and has been endorsing first. He's and last year at the competition, he and the Black Eyed Peas did a concert, but he's like, when he's hanging around his friends, it's like, what's cool? And he says, these guys at first are awesome. And he really likes coming to the competition, talking to us and watching the matches. He's actually going back to college for a computer science degree next year. Kareem Abdul-Jabbar, the famous basketball player, he was there this year. He got onto the field and was measuring one of the stacks, which were over twice his size. It was twice as tall as he was, but he was out there. He's endorsing first, and he really likes it. I mean, they see that this is our future. We are the future, and that we need to give this to everyone, not just those schools that like Essex, that bigger schools, but inner city and all those type of the places like that.
Right. What did you like about what stood out the most about the first?
Just the entire, the experience was very interesting. I mean, this was my first year on the team, and something that I've noticed throughout the year is how first teams interact with each other. Right. And it's something that really stood out to me, and it's something that breaks a lot of the barriers of how teams collaborate with each other, not just inside of the team, but the teams need each other to support one another. For example, there are a lot of challenges that we can look at as a team and come up with one solution, or we can come up with multiple solutions and decide that one's the best. However, when we come up with those solutions and multiple teams come up with different solutions, it's very open. It's very easy to look around and talk to other teams and get ideas from them, and in turn they get ideas from you. And I think everyone that's involved sees the value in collaborating so that your team can have a really great build and a really great robot that just works excellently.
Now there's a term for that. You remember what that is?
Collaboration.
Collaboration, yes, absolutely.
I think I do. I think it's on my wrist right now. And it's gracious professionalism.
Yes,
it's an element, a very strong element of first.
Yep.
And like Matt was saying, nobody wants to spend all that energy, all that time, to put their robot in a ring for 5 minutes and get it smashed to pieces. Actually, we did sustain a lot of damage our first robot, and it was first year involved in first, and it was heartbreaking to see the bolts and nuts come off the thing and have to collect it after the matches. But to see all these students from all over the globe, from not only America but from Asia, from Europe, from Africa, come together and to really believe in that gracious professionalism is an amazing thing. I think we've got some pictures of the event and how many people were involved, and I think we're going to see a picture of the FTC event. And here you can see the stands, and again, this is about a quarter, showing about a quarter of the Edwards Dome in St. Louis. And on the red carpet there, you can see the FTC arenas.
And that's just one competition.
That's just one.
Yeah, it's one. There's
it's about a quarter.
There's a first Lego League, which is more for the younger students that they have their own competition, they have their own field and rules, and they build their bots and program their bots. And then there's One Up, which is the first robotics challenge, FRC, where they make these huge $30,000 robots, and they're on like a basketball-sized field, and they have their own tasks and their own challenge, and
they only get 7 weeks to do it.
Yeah, they only get 7 weeks or so to do it, and it really gives you that good experience of what the real world is like. And I don't know any other program or program that does that for you.
Mm-hmm. You had some other shots up there.
Yep, we've got some other pictures here too, and here's Joe Chase, the other coach that we're talking about, myself and John Bear, and yourself, Doug. These are the pits. So next to the arena, you've got again about 20,000 people that have to have a place for the robot to work on the robot, and the pits are not just a table to work on the robot, but they're also an area that you can display lots of things about your club, about your team. There's lots, you can see us in our hats. And I just want to point out also all of our sponsors that helped us out that are on that banner. Heritage Ford, Heritage Auto, Speeder and Earls, University of Vermont, of course Green Seas Systems. We worked side by side with them for about a month. And Hazel Strip Casting, all these people donated, all these businesses donated good money to us.
Now they donated time and money.
Time and money.
About how much does it take to field a team to go to regionals and then go on to the nationals?
Well, that's a good question. I haven't summed it all up yet. Joe and I haven't done that homework yet, but it's about it's $1,000 just to enter a regional competition, and it was a couple $1,000s to go to the nationals, and it takes about $3,000 for so all in told with travel expenses about $10,000 to $12,000.
Yep. Yep. Okay. Great. Now, is there any way you can start this up here?
Oh yeah.
Show a couple.
So
got a few minutes here.
we have this is our robot Bordeaux, as we showed you earlier. This is what Matt is moving right now is we call it the T-bar, and it guides crates that we have to flip crates around and put racquetballs into the crates before we lift them. There's a collector, there's a hopper in the back which picks up racquetballs, and then there's actually a little servo toggle that opens and closes in there that allows us to drop the balls into the crate. Matt, if you want to make sure that crate is all the way back in there. So we have these tread systems in the middle of our robot that actually, they clamp together onto the crate, and then when I'm ready, I can pull up the crate into our scissor lift, and right now it's a bit stuck. It does this sometimes to us.
Let's bring it apart and bring it down.
These are some of the challenges you face. Huh?
Yeah.
Right.
No
Yes.
competition.
I mean, even after 6 months of work,
Yeah.
there's
Can you bring it down a little bit there, Brian?
There you go. Yes.
We may have shifted a bit during our travels through the box, and
We just
there
got it
you
back.
go.
We just got it back.
barely
today.
got it back from the shipping center.
Oh, okay.
So at the top here we have a scissor lift system that actually
Uh-huh.
it locks into place with a Chinese finger trap system is what we're calling it. So the crate can go in, but it can't come out through the same way.
I see.
And then when we're ready, we essentially just start lifting our scissor lift, and it lifts our crate. So it goes up and up and up. And actually, this is another challenge that we faced here,
Keeping everything.
where it's going to keep tipping. So it can go pretty high, but it does tip. And this is just mostly because the material, the way we've constructed our scissor lift, we had to cut it down a bit at the competition because we decided that we'd rather be able to lift it than have it barely be able to go anywhere. So it was a last-minute modification, and it comes down to just using different materials, I guess.
now.
Yeah. We
Now
can
at-
improve it. But
Now at this competition, we could probably go four feet or so, about this height. There were robots there that were lifting 2, 3, 4 of those crates 14, 15, 16 feet in the air consistently. And that shows you, like, given a task that we all enjoy, how innovative students and people can be.
Mm-hmm.
And it was a lot of fun seeing Kareem Abdul-Jabbar going out there and having to look up to something for once.
Yeah, right. Yeah, that's cool. Now, as far as the goal of this is to get as many balls and crates in the air as high as you can get?
Originally, there's a game design committee for FIRST, and actually let's see if we can. Well, we'll stop buzzing now. So there's a game design committee for FIRST, and they're based at the FIRST intergalactic headquarters in is it
Manchester, New Hampshire.
Manchester, New Hampshire.
Oh,
So
just
just down the interstate, get a bit. And during the summer, probably they're starting just about now. Actually, they don't have much of a turnaround time. They start designing the challenge for the FIRST LEGO League, the FIRST Technical Challenge, and the FRC, which is the FIRST Robotics Challenge. Originally, the intent of the systems was, or the game was, to stack crates on top of each other as high as you could go. But there were a few teams that started to realize that their crates didn't have to touch the ground, and that the way that they were scored was with the scoring stick, and it was all based on the height of the crate. And so it actually surprised FIRST. It surprised the game design committee when they first saw scissor lift systems being used. And
they only expected robots to go 7 feet or so. They never expected something like this happening.
And they expected the crates being stacked on top of one another on the ground for the most part. And it added for a really interesting, innovative challenge. But it wasn't very dynamic this year, but it was there were some really cool systems that did the job.
Cool. Now, what are your plans in the future?
Well, our plans are, of course, spread the word of FIRST. I mean, 3 years ago, they had about a little over 1,000 teams. 3 years' time, so they got over 2,100. And it shows, just in the FTC alone, and this has been around for 6 years, and shows that it's really expanding. It's a really big thing to do. We do a summer camp that we run every summer, and then when school comes around again, we're going to wait for that challenge and have a lot of fun doing it.
Great. Good. And as far as career goes,
I'm looking forward to hopefully next year, not next school year, but the year after that, maybe majoring in computer science. I'm not sure of my path yet, though.
And I'm going off to Clarkson.
All right.
Where I actually received the first scholarship that they offer for civil engineering.
Great.
And that's another thing to mention about FIRST organization is that they have millions of dollars of scholarships available to students, and companies are really lining up because these are the types of students they want. Well motivated, very focused, especially after doing this. You can hear it after doing this kind of competition, where now they know what they want to do, and they have experienced it, and the hook is in.
That's great. Well, good. Well, Jim, Matt, and Brian, I want to thank you for being on the show.
Well, thanks for having us.
Yeah,
Thank you.
I appreciate you coming out. And thanks for bringing your robot as well.
Yeah, Bordeaux enjoyed stretching his muscles there after a long trip home.
Yeah, I bet. Well, my guests today were Jim Dermeyer and 2 of his students, Matt and Brian, from the Center of Technology in Essex. They discussed robots in education and their recent trip to compete in the FIRST robotics competition in St. Louis. For more information about this show, related internet links, and other shows in this series, go to retn.org and look for robots. Thank you for joining us.